Hey there, grade nines. Welcome to lesson 4 of chapter 4. In this lesson, we're going to be talking about matching equations and graphs. So I'm going to be sharing my screen for most of this lesson because we're going to be using this website that I've previously used with you. So with this one, I'm just going to cover up what you might want to see, just so that there's no kind of cheating going on. All right. So with that being put in place, let's get started. So in this, we've got 3 graphs here. So basically what we're doing is we're comparing 3 graphs that all go through the origin. Okay, so when we're talking about that, so we know that the constant in each of these is going to be 0. Okay, so my question for you, and you can feel free to pause the video, is what is each of these graphs? Okay, so when we're looking at, let's say, for example, the red line. Okay, the red line, even if I zoom in a bit more so that we have individual numbers on our X and our Y, what we're looking for is as it changes by 1, how does it go up? Okay, so it goes up, it goes to the right 1, it goes up 1. So what might that expression be? I'll continue to use the annotate here. Some of you might be able to understand that if it's increasing by 1 for every time it goes right, that means my numerical coefficient is going to be 1 times x, or we can say y equals 1 times x, or I can actually just get rid of the 1 and just say y equals x, right? So that ends up working out in that sense. Okay. Now, if I move on to the blue one, so let's actually draw in blue just to make it work. So as I'm looking at it, as I see that it moves over 1, it's going up by 2. Okay, so my blue one I can represent by saying my numerical coefficient is going to be positive 2 x. So I can say equals y or y equals 2x. Doesn't matter which way I do it. Okay. And then for the last one, the green one. Now I have an opposite slope. I'm gonna, whoops, let me erase that quickly. I'm just gonna move this down a bit so you can see. So for this one, as I'm seeing my slope, so as it moves over, so I'm looking at a constant point here, and then it gets to the origin, and I can tell that it's going down, so I'm gonna have a negative numerical coefficient. So I'm gonna say y equals, or I could just put it in first and say it equals to y. I'm gonna have a negative, but what? So it's going down, so every time it moves over 1, so from this point to this point, it's decreasing by 1, 2, 3 units. So equals, oops, 3x. Try to draw that one a little fast. Okay, so y equals negative 3x. Well, let's see how that actually worked with each of them. Well, I had x, 2x, and negative 3x. So each of those were correct. All right. Now, let's move on to the next page to try to see what we had. Oh, I need to get rid of this stuff. Okay, so this one in particular, I am actually looking for, the equation y equals 3x minus 4. Okay. So the first thing that I might want to check with each of these is, what's my slope? Okay, what's my slope with each of these? So let's take 2 points, for example. Let's take this point here. So we've got this point here, which would be negative 2, or what? I'll zoom in, actually, once again. Maybe it'll make things a little bit easier. Oops. Here we go. Yeah, that's better. Okay, so let's get rid of that. Let's try this again. So let's start with, I might have to go to, let's start with here. So I've got point -1 and -1. Okay, so as it moves over 1, how high up is it going? Well, it's going to 0 and 2. Okay, So I can see that my increase is 3, so that would mean my slope is also 3. Well, this one, let's start at 0. So I've got 0, 0. Sorry, these are my brackets. And as it moves up, it goes all the way over to 3. So I've got 1 and 3. Okay, so as it moves over 1, it moves up by 3. So that means my slope, or my numerical coefficient, is 3. So far, both of these ones work. Let's look at this one here. So let's take this point. So we've got 1 and -1. Okay, and then let's go, it goes up to 2 and 2. Okay, so whoops, let's check the slope. Well, as it moves over 1, it goes up 1, 2, 3. So that one still works. So all of them so far seem to be working for exactly what we're looking for. Okay, I'm gonna have to zoom back a little bit more. The next thing that we have to look at is what our numerical coefficient. Okay, so let me just erase these ordered pairs. My constant. My constant tells me where the line crosses through the x-axis. Where the line crosses through the x-axis. Well, in the green one, it crosses through at +2. So that means my equation would be 3x plus 2. That's not the one I'm looking for. In the second one, it crosses through at 0. So that means I wouldn't have a constant. So my equation would be y equals 3x. And this last one, it crosses through at -4. Okay, which that means that would be my correct equation. So let's see if it's the red line is the one that's right. So 3x plus 4, 3x plus, or -4, sorry, -4. Okay, so that's the one that actually works out as being the correct one. So you're just going to be given a whole bunch of examples, and you just have to represent or say which one is representing the correct graph with the equation. Okay, so you get some practice of kind of going back and forth. Once again, if you have any questions at all, contact me through Hangouts. Bring your questions to Zoom, and then we'll go over those questions together. All right, have a great day.